Hi, my name's Kevin, and I'm joined by Z, Wilson, and Alexander. And for our product examination project, we decided to take apart a Logitech mouse. There are 10 key components to the Logitech mouse. There's the plastic housing, the scroll wheel assembly, the circuit board, the switches, the screws, the metal weight plate, the buttons, the mouse skates, the internal structures, and the springs.
The mouse shell is likely manufactured using injection molding, evident from the visible gate marks on the interior, which indicate connection points to the runners. Injection molding is suitable for this part due to its complex shape and high volume efficiency. However, it has a high initial cost because of the molds required, making it inflexible for sudden design changes. Alternatives like thermoforming and 3D printing are less ideal. Thermoforming can't handle the shell's complexity, and 3D printing is inefficient for high volumes. The internal structure that holds the scroll wheel is likely manufactured using progressive die stamping, which shapes and cuts metal sheets through a series of dies. This process is suited for the part's complex bends and curves, requiring multiple stamping passes. The uniform thickness suggests that it started out as a flat sheet. Like injection molding, progressive die stamping is efficient for high volume production of complex parts at a relatively low cost. Alternatives like sheet metal bending and laser cutting would not match the efficiency of progressive die stamping.
So for the metal weight plate component, our team has assessed that the key manufacturing process to make this component would be metal casting, or more specifically investment casting. So the pros of this process would be high production efficiency, less defects, accurate tolerances to align the component in the mouse properly, and affordable tooling. However, the cons of this process is that it has high pound cost because you would have to remake the mold for every single time, and that costs money. And alternative processes would be CNC machining, laser cutting, and other methods of casting such as die casting, sand casting, and etc.
In regards to the screws used in our mouse, they're most likely manufactured through the process of thread rolling. We believe thread rolling was used due to the context of our product being mass-produced. When mass-producing screws, the thread rolling process is a more cost-effective and time-saving process, making it better for high-volume production. Thread rolling also provides advantages such as improved strength and fatigue resistance, but these factors are not as important for our product, with being only an office mouse that will not experience heavy loads or stress. Alternatively, these could be machine threads, but it makes more sense for them to be rolled threads due to high output requirement. Machine threads also have the pros of wider material choice and good dimensional accuracy. However, it is a slow and costly process, making it not ideal for high outputs. The finishing process was also done on these screws, that being black oxide coating, which is inexpensive anti-corrosive surface finish.